This is the code for Lab 8 PWM RC Servo controller. We start by setting the module 0 for the TIVA board TM4C1294. We're going to be using generator 2, GE and B, PWM5, and the port control register value of 0x06. We enable the clock for the PWM module 0. We enable the clock divider for the PWM timer. We also set the value of the PWM divisor, which I chose to be 16. We disable the PWM generator and set up the timer counting mode. Then configure the load and the CMP values for module 0 generator 2. The load value was 20,000, CMP value was 18,500 for center position. Then we enable, and also it's a left align PWM. Then we enable the PWM generator and the PWM output. For GPIO, I chose port G, pin 1. So we have to enable the clock for that GPIO. We set the port control register value to 0x6. We also set the alternate function for pin 1, and we digitally enable pin 1 as well. Going up to the main code. The main code would be rocking the RC servo arm back and forth from 0 degrees to 180 degrees at a 5% increment. So I define the direction. 0 is clockwise, 1 is counterclockwise. We have CMP 0 for the value of 0 degrees, 180 for the value of 180 degrees, which were 19,500 and 17,600. I'll show how those values were found later on. We start off by setting the CMP value to CMP 0, and the servo will start to going counterclockwise because it's going to be going to the 0 degree, which represents the 180. So it's going to be decreasing at a 95 CMP increment, which is the 5%. This is the 5% increment that it will be decreasing from 19,500 until it hits the 180 degrees, and that is gonna set it to the value of CMP 180, which is 17,600, and it will change the direction from 1 to 0, making it go clockwise. Then we get out of this if statement, and now we're in the direction of 0. And it's the same as above, but it's going to be adding 95 now as the increment instead of subtracting to our CMP until it hits the 0 degree, and it's going to be going back and forth while always continuously being updated into our servo. And we also have a 50 millisecond delay. This is the calculations for Lab 8 with our pulse width range of 0.5 to 2.4. Our system clock is 16 megahertz, PWM divisor at 16. The frequency for the servo is 50 hertz. The frequency for the PWM timer is going to be the system clock divided by the PWM divisor. So 16 megahertz divided by 16, that gave us 1 megahertz. The load is the frequency of the PWM timer divided by the frequency of the PWM servo. That's 1 megahertz divided by 50 hertz, which is a value of 20,000, and it fits the criteria of being under 65,535. To find our CMP value, we must first find our duty, at our specific degrees, 0 degree and 180 degrees, which is just the pulse width at that degree. So 0.5 divided by 20 for the duty of 0 degrees, which is 1 over 40. And then we use this formula, which is the load times 1 minus the duty. So 20,000 times 1 minus 1 over 40. And it gives the value of 19,500. Similarly, for 180, it's just 2.4 instead of 0.5. Give a value of 3 over 25. Plug it into the formula again, and we get a value of 16,000. Now for the 5% increment, it should be between the CMP values of 0 degrees and 180. The difference between the two. So we take right here, we take 5% of the difference, which is 95. So that's why we add and subtract 95 in the code. This is the connections for the RC servo. Here it's connected to pin 1 on the top left hand side. That is the blue wire. Port G pin 1, and the top right hand is the brown wire, which is ground. The connections for the servo, the orange is the left, that is the PWM signal. The middle red is 5 VCC, and the brown is ground to our power supply. Just rocking back and forth. From 0 to 180.